This video is going to be on systems of linear equations and the algebra we use to solve that. Before I get into solving particular lines, I want to talk about what this means. So if you see this notation here and two lines like this means I want the set of all points that satisfy this equation and this equation. So since these are lines, we can interpret them as being, so if this were the xy plane and one of my lines, say, looks like that and the other line looks like this, I know this point right here is going to be the xy value that I'm looking for that satisfies those two lines. So in other words, the solution to a system of linear equations can be a point, but it can actually, we can have other solutions as well. So there, in the xy plane there are three cases. There's going to be, you have an intersection point. That means these lines are not parallel and they're not coincident or collinear. If they are coincident, that means they're the same line. That means this is a multiple of that. And then when I get into solving, I'll show how the algebra determines if it's collinear. If it's collinear, it's the same line and it has as many solutions that are on the line. So the solution is the line itself, actually. And then we can have parallel lines. If we have parallel lines, we can see there aren't any solutions on this plane. And I want to make one more point because it might be important if you want to study linear algebra further. If we're talking about systems of linear equations in 3 dimensions, then not only do we have to look for parallel lines that have no solutions, we also have to look for lines that are called skew lines that have no solutions. In other words, we could see this line as not being exactly parallel to that line. Maybe it's skewed and it's facing this way, and then that line is facing that way. These are called skew lines, and they have no solutions either. So either they have a solution at one point. Well, if we're just talking about two equations in 2 dimensions, it has 3 possible solution sets. It either has one single point of intersection, it either has no solutions, or the solution is the entire line itself, if they're the same line. Okay, so now that we've discussed that, let's do some example problems. Or maybe I'll just do one example problem and then I'll do a whole other video with more example problems. So let's say 3x plus 5y is equal to 1. That's one line in our xy plane. And then let's say x plus y is equal to 3 is another line that I'm solving for. So one way I can solve this is I can solve for one of these variables and substitute that variable into the other equation and then solve for x and then go back to this equation and solve for y. And I think I'll go ahead and do that. So taking this equation, I know y is equal to 3 minus x, and then I'll substitute that into the first equation. So I have 3x plus 5 times 3 minus x is equal to 1. Now I can just solve for x, so I'll have 15 minus 5x, oh, I'm sorry, 3x plus 15 minus 5x is equal to 1. Or I'll have negative 2x here. 15 minus 2x is equal to 1. Or I'll subtract 1 from both sides and add 2x to both sides. And we have x is equal to 7. And if x is equal to 7, then y has to be equal to 3 minus 7, or negative 4. So this has a solution at 7, negative 4. So if I were to write this, if you saw this, this means the set of solutions for this system of linear equations. And that set is going to be one single point, and the point is 7, negative 4. Alright, I think I will end on this note, and then I'll make another video with more variety of examples, and maybe I'll do some examples in which we have parallel lines, and actually I think I will talk about systems of linear equations in 3 dimensions too, because that seems like the logical next step to talk about. And then just know that we can talk about higher dimensional space as well, once you understand the operations of how to solve these systems of linear equations. So this is matrix operations that we're going to get into. That's a subject for probably in the future. I'm going to cover that.